All right, class. This is, I don't know, I think week number 3 of RStudio. The first round of RStudio, this was your product, right? You just created a simple bar plot that had yield on your y-axis. This is tomato yield. You had the soil treatment, the no-till with cover crop, your tilled soil, and your tilled soil with cover crop. On the x-axis. Now, we're just going to go through this week, more or less finishing up a little bit of that package work. And we're going to introduce 2 packages. We're going to introduce PLYR and ggplot2. Now, I think most of the folks in this group have experienced packages before. Packages are what make RStudio and the R statistical computing environment really what it is. It takes what looks like a plot that you can make in Microsoft Excel, and it turns it into something a little bit more aesthetically pleasing. It does a little bit more to put data sets together in the form of a more effective grid system. So instead of having to calculate means by hand for each treatment in Excel, or doing it the way that we did it with the aggregate function, we're more looking at these packages that can do mean, standard deviation, standard error, all of that, all in one quick and effective line of script. So I assume at this point you've all been successful making this plot using base R. And base R is a little bit, cumbersome. It's not hard to use, it's just cumbersome. Now, what I'm going to ask that we do now is start by installing packages. These are installed on your computer. So we're going to have this section as using packages. And again, we're using these hashtags to block off a section of line. We can do this with the install packages option, and we can do PLYR, or we can do that with ggplot2 as well, or we can do this by clicking packages, install. We're pulling from the CRAN repository, bringing it onto our own library on the computer. I'm using R4.0. We just type in PLYR. You see it finds it for us, or classic ggplot2. All right. You'd load ggplot2 or select ggplot2 and click install. I've already got it on my computer, so I'm going to skip that install step. So either install it through the packages or highlight this and click run. Now, when you have these installed, and you see I've got this huge pile of library or packages here in my library. That's a lot of stuff. We don't want that running at every point in time. It adds a lot of, it makes it just as cumbersome as base R if we have all of these packages running at once. Instead, what we do is we set library or select it from our library and we call it out. So we can type in library, PLYR. We can do the same for ggplot2, since these are the only 2 packages that we're going to use today. And you should see if we highlight them, click run, we should see a little check mark next to these now. So we'll find ggplot2. What the heck? Why isn't it working? We're just going to select it by clicking that little box instead then. And let's see, PLYR. We'll just click it anyway. All right. So we now have access to all the shortcuts, all of the functions of these packages. All right. So you've got the packages loaded, the packages ready to go. Let's make use of them. The first thing we're going to do is something similar to aggregate. We're going to do, we're going to use PLYR And we're going to generate something very similar to what we did earlier, right? If you remember back with aggregate, we're just using this to calculate the mean of the class data set for the treatment, right? So getting our tomato yields, the yield averages for each treatment across replications. We do that to get the standard deviation as well. We call that a tomato SD, right? Yield in tons per acre, standard deviation, and our treatment. Now, if we want to put all of that in a single matrix, we can do that pretty easily using the PLYR package. So let's call this summary class data. And we will do DDPLY, perfect. This is for each subset of a data frame, apply the function to combine results into a single data frame. That's perfect if we want to merge all of these into a single matrix, a single grid, a single data frame. To apply a function for each row, use ADPLY, but we're going to do this across with DDPLY. We're going to type in class data, which is where we're pulling this from, our data frame. In this case, I'm reading data frame first. And we're going to call out specifically treatment. And then we're going to type in summarize. Summarize is another function in PLYR. It's to summarize works in an analogous way, putting it all into that single data frame. Okay. So with that, n equals length. And a lot of these, whoops, clicked that too soon, didn't I? A lot of these functions will just take time to get used to. When you're working with these data sets, these packages, maybe I should pull this up before I get too far into this. So if I click PLYR, pulls up help, and we see that this help page gives us all of the functions as a single library, a single set of tips that we can scroll through. So we can say DDPLY, split data frame, apply function, and return results in a data frame. It's useful for what we're doing. We can look at whatever part of this you want. All the tools, all the functions of PLY are shown here, right? So let's go back to this script. We're doing n equals length, and n's just something that I'm calling myself. I'm just calling n. Doesn't matter. You can call it file, right? You can call it whatever you want. N equals length, and we're going to pull this length. It's just the number of observations from the tomato yield data set. I'm sorry, the class data data frame. These two are the ones that we generated previously. So you can click class data. And what do we want? We want to generate these for yield tons per acre. Okay. All right. And we'll see more where this fits into the story later. I wouldn't worry about it for now. We're just using that n to eventually calculate standard error. We're going to do mean. And mean, we're going to call mean, right? We're going to do this for, again, yield tons per acre. Easy enough. We do the same for standard deviation. And we're also going to just calculate for the heck of it standard error, just so you can see what this data frame will look like. And standard error is going to be calculated as standard deviation divided by the square root of n. SQRT, we see this is from base R, square root of n, right? We can easily swap out n with x if you want to do that. It doesn't really matter. Move this down here, then type in summary, and our object is, actually let's do summary class data. All right, let's see what this gives us. Oh, there's an error. Okay, so we have an error in here. We have to figure out what it is. Why didn't it work? We see that this didn't give us a new data frame. We can scroll through a little bit and maybe figure it out here. I'm not getting a lot of clues from the console. It's object n not found, unexpected symbol. So something probably happened on this line or above. Oh, I wonder if this is my problem. Treatment singular instead of plural. That's not right. Why isn't that right? Well, let's see what else it could be. CUMMARISE, N equals length, yield, tons per acre. Okay. I think this is my problem. There's no equal sign here. Let's see if this gives us anything better. Okay. So it takes a little bit of time. If you make a mistake, that's okay. Don't panic. Just take a little bit of time to read over your script, right? It's easy to add an S to treatment. It's easy to forget an equal sign. Just take a minute and explore the functions, right? We have this base function of division and square root. We have all of these things coming together to make this script work from base R and from PLYR. All right. So we see that this summary class data, if we just type that, it throws it in the screen here. We can view it instead of clicking summary class data or data frame. Either way, they read out the same. N, that's our number of replications, showing 3 per. That's a good sign. That means our data frame is still good, our data set. And these values look identical to what we had calculated before with tomato yield, right? 31.6, 34.6, 45.3, 47.6. And we see the same values here. Perfect. Now, what we really did just now is we combined our tomato yield data set, tomato yield standard deviation, SD data frame, and our tomato yield data frame into one. And on top of it, we added standard error, right? Because we chose to add that into the story. And we chose to add the number of replications with that variable n. Okay, so that's pretty useful. I recommend getting familiar with PLYR. It's a valuable package. The next package that we're going to look at is ggplot2. We're going to do the same thing that we did last week, but with packages, right? So if you pull up ggplot2, you see that this is a very, 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 we'll call it rich tool, a rich package. You have a ton of functions in here, right? We can add borders, we can set aesthetics with colors, and draw lines, adding a line of a certain slope is going to be important for, say, regressions. If you want to add that one-to-one line. Facet grid, That's something that you'll probably use at some point in grad school. Same with facet wrap. These two are very similar, but they have slightly different functionalities. Geom bar, make bar charts. That sounds like it's going to be important for today. And one of the things that I encouraged some of y'all to do, and I think one person did it, was add error bars, Geom error bar. So that's nested right in there. We don't have to add on top of a picture, right? Whole bunch of goodies, labels, labs, modified the axis. Let's see, scales. Scales are going to be important if we want to scale it continuous. Set limits on our X or Y axis. Huge list of items, and theme is a very valuable one. That'll gives you a lot of functionality for the aesthetics itself. Okay, I think we spent enough time looking at this. We can't go through everything in a video. I encourage you to take time to go through these to just get a general feel for them, see what you can do. Okay, so let's work our way down here a little bit, and we are going to use ggplot2 to make the same bar graph. All right, let's work through this one step at a time. So the first thing we're going to do is call it our package, or our I guess calling the package itself that initializes, it initiates the use of ggplot by typing ggplot. And as you've probably figured out from the way that we set this up, data, we just type our data in here. We're going to do summary. Oh, summary class data. There we go. That's our data frame. Now we're going to use the AES option. That's the aesthetics mapping to describe the variables that are in the data that are mapped to these visual properties. I suggest we see X and Y on here, setting our axes. I suggest taking a look at AES in the package help. So we'll do X equals treatment. And Y equals mean. We'll even do this so it looks a little bit better. All right, will this work? No, why won't it work? Well, it doesn't work because we haven't really set it to do anything yet. We see that we have mean on our y-axis. That's a good sign. We've got treatments on the x. So we have that base level of it, but we need to add to it. So we're going to add. And first thing we should probably think about adding is the bars, right? The bars are clearly missing. So we're going to do geom bar. And that's setting our bar chart, right? Our bar graph. I'm going to maybe start by setting its positioning, position the bars themselves. I'm going to do a position dodge. That's just preventing that overlap. Position dodge, easy enough. We don't even have to put anything in here unless we want to set something specific. Whoops. Stat equals identity, IDENTITY. There we go. Size, it's just sitting itself. Size equals 0.5. And let's see what this gives us. Notice this shows me, this is highlighted, this shows me where the parenthesis ends. We need to add one more. If we just run it like this, we should get an error message. Oh, worked out. What did I do wrong there? What the heck? Oh, just can't count. All right, so we've got our bars in this actual plot now. This is not so bad on its own, right? It's just kind of a not quite as attractive version of what we made earlier. Now, we can add more to it, which is part of the beauty of ggplot. So let's add error bars. We talked about those error bars before. Let's keep talking about error bars. Now, the error bars are something that you will have to set yourself. We can use standard error or standard deviation. So I'm going to do AES again, the aesthetic. And I'm going to do a Y minimum value equal to the mean itself minus standard deviation. And I will do the same for Y max. That's pulling that mean that we see up here, right? Whoops. Let's be careful with that one. If you have a name that's the same as a function, mean plus standard deviation. Okay. Let's see what we get from this. Nothing. Ah. Let's try it now. So what's gone wrong? Let's maybe think about adding a little bit more to it. Geom error bar AES Y min. Ah, I see. We can think about doing a little bit of additional specification to it. Let's do width equals 0.5, size. Oh, wait a minute. I see my issue. Ah, it does not pay to get ahead of yourself, does it? Sometimes, like I said, just looking over one step at a time where that mistake might have been. In this case, I put an extra parenthesis after my Y minimum, right? That wasn't needed when we were setting our minimum and maximum in that same aesthetic. Okay. So this is working now. That's great. We generated this plot with the bar graph. And if you want, we can even swap it out for standard error. If you'd rather plot it with standard error, we see that that changes, right? It's a smaller value, so some of these bars shrink. Let's stick with standard deviation just because that's what we've been talking about a little bit already. Okay. Now let's do this. Let's add the width to those error bars using width 0.5. And let's set the size of it. Size, let's do, so width will be half of the bar. Size is, let's do 0.8. And let's again do that position dodge. So let's throw that on there. Position equals position dodge. And let's use this actually. Let's make it 0.9. Okay, let's see if we did this right. Okay, so we see that they're smaller as expected. What if we made this 0.5? Just see if anything happens with that. Nothing really. So we probably don't need that for any part of this. If we change that size from 0.8, and it might be something that we can't quite visualize in this box here. We can always click export, save as image. We'll get a slightly better view here. What if we change that to 0.4 for the size? Run. Oh, so we see that's a little bit smaller of a bar. That's good to see. What if we change that width to 0.7? We see it expands a little bit. Well, let's put it at 0.6. Feels lucky. Yeah, that looks pretty good to me. Hope it looks good to you too. So again, this on its own, it ain't so bad. This is pretty good, right? But you know, y'all are graduate students. Let's keep expanding on it. So we're gonna go to another function now. Let's add that plus. Go down a line. Now you see we're lined up with those functions. Let's do. Let's set our y-axis. I think our y-axis is pretty good right now, but we can modify it a little bit. Scale y continuous, and we're going to expand. We're going to set this so instead of having it floating, we're going to bring it into 0, 0. We're going to do expand equals let's see, c 0, 0. Limits. We can set our limits here. Our y-axis limits. Let's do c 0, just for the sake of demonstration, 75, right? We probably don't actually want it to be quite that big of a range. Breaks are these set points, the ticks. Breaks equals c, let's do 0, 20, 40, 60. Sure, that's good enough. Let's see what we get now. Okay, so you see we expanded this. That's a little too much. We don't need that much space up there, do we? So let's take this down to about what it was actually at before. Sometimes you'll want to set these on your own anyway. Let's do, let's see, 0 to 55. So let's do 0, 10, 20, 30, 40, 50. And you'll notice we're at that 0 line now. There's no weird gap since we set that expand point at 0, 0. I think this looks pretty good. This is looking better. This is looking a little bit more aesthetically pleasing. Another thing that we'll want to do is we'll want to probably set our labels, and we can change the treatment or the mean for this, right? So let's change both of them. I think treatment's probably what we want, but for demonstration's purpose, let's add labels for both. If you remember from what we were looking at before, label is labs, L-A-B-S. And we're going to set our x first. X equals, and we're going to set ours as an expression. Expressions can be pretty useful. It'll allow you to, say, put superscripts or subscripts or set some additional functionality into your axis or your axis titles. Let's make it bold. Bold's always fun, so we'll just type in bold. And let's just call it what it is. Treatment. There's no point in us getting too fancy. Let's also choose our y-axis label. Y will be also an expression. Bold, because you know bold's kind of fun. And let's get a little bit more creative than mean this time. Let's call this tomato yield. Oh, and I like to make my second line lowercase. Let's see what this gives us. Tomato yield, treatment. We don't have our units on here, so we can do tomato yield. We try tons per acre, right? We think, okay, It's not bad. I made something like that before. But when we have tons per acre, we usually want to superscript that -1. So we have this as an expression so that we can do that. Let's go ahead and add to tomato yield. We're going to put a little squiggly mark. I forget what those things are called. And we're going to, it's saying that we're including some additional, right? We're going to add tons per acre, right? Let's see what we get from that. So you see how it's just connecting tons per acre. And then once we have that in there, we can add that superscript functionality. So we go outside of that parentheses, use your little up caret guy, whatever that's called. And we're going to use one of these fancy squiggly brackets and do -1. That's just telling it to put that -1 value on there. Let's see what we get. Okay, that worked out surprisingly. Tomato yield in tons per acre. Got our superscripted -1. We have our treatment. Okay, that's good. We can work with this and we can call this a pretty solid graph. We can export that with this function here. Save as image, save it in whatever directory you want on your computer. You can set your size a little bit more if you want. You can call it, I don't know, 1000. Whoops, well, that's saved anyway. And you click save, and there it goes, our plot 01. It's a pretty big deal. You can mess around with it a little bit. You can remove that check mark and maintain aspect ratio. And when you have that checked, you're just set with that same kind of ratio. If you uncheck it, you can do all sorts of fun things. You can make it a little wider plot. You can make it a tall, skinny plot. And that's kind of fun. But when we're writing, when we're making figures for manuscripts, we usually want to be a little bit more artistic, right? This is our baby going to press. So let's add that plus there. And another item that you probably remember is theme. Theme's going to allow us to do all the big aesthetic items at this point. So with that, we can do something like panel. Let's start with a panel border. Border on the plot area, drawn on top. I like borders. Borders are kind of fun. Some people don't. And this is going to be element. And we see we have these options for element. We're going to do a rectangle because it's not text. We're not trying to make it blank. We're going to do element rectangle. We're going to do color equals black. And fill equals NA. I got this down here. Okay, we got a border. That's pretty cool. Let's add some other items. One thing that I don't like are those gray grid lines. I like that nice, just plain white background. Grid lines are just too much for me. So let's do panel dot grid. And you might have guessed it, element blank. Do that for the major and the minors, right? So let's do the same thing, panel dot grid. Actually, let's just take care of all of them. We just did panel grid. Let's see if that works. Okay, we have no grids. Took care of the major and the minors all in one nice swoop. Let's make our background white. Plot background element. In this case, it might not seem obvious, but we're going to make it a rectangle. because we want it to actually have a fill. We want that fill to be see if that worked. That didn't work. Why didn't that work? Maybe it's panel background instead of plot. Let's see, is there a panel option? Let's check our packages. These would both be in the P's. We have to go within theme, don't we? PQRS theme. Okay. We can sort through all of these goodies. Panel. This is panel background, is what I was looking at. Underneath. Let's see, plot. Plot back. We want plot, don't we? Where's the panel? I can't remember now. We wanted panel background white. Okay. So again, it takes a long time to get really familiar with these. It takes a little bit of guesswork to get it sorted out, and it takes time to get used to these systems if this is your first time doing any scripting. So don't get discouraged. What else could we do that'd be kind of fun? Let's see. Let's rotate this axis a little bit, our x-axis. Let's do axis dot text. And also want to do it for the x-axis, text.x equals element text. And we're going to do angle equals 45. Let's see what this gives us. That's tough. We don't want that to happen. So let's do a tool called height adjust. Adjust equals, let's see how 1 treats us. Okay, that looks pretty good to me. We can also modify the text itself at this point, since we're already on that topic. Let's do strip text. Let's do strip text equals element text. Face equals bold. Oops. So nice. RStudio just finishes up with that quotation for me. Okay. Let's do strip text. Maybe we want to do this as actually axis text. Axis text, element text. Let's set a size and a color, actually. Let's do size equals 10 and color equals black. Let's see if we have any good changes here. What? I have a little bit of bonus stuff happening after 1. So go back, click run. Uh-oh, disappeared. Because we want 10, not size 1. That would do it. Okay, so we've got a size that we think is pretty good for that. I'm pretty happy there. Any other items? I think this is pretty good. I think this is pretty good. What we're going to want to do at this point is take this up here. Okay, so we've made our plot. This is pretty good for our case. Let's save it in a very specific way. Let's save it differently than we would with that export. We're going to name this. We're going to call this, I don't know, let's call it class figure. So we run this again with that class figure being equal to. We see that this pops up. We have this huge amount of detail on here that we don't need to see. And we can do a function called print. We can call this print class figure. All right, we see it already. Nothing should have changed. And let's use the GG save option. We're going to save this, I think, to that same folder that we started with up here, right? We have in GCoHire our class. Let's save it to that same folder. So I'm going to do C, users, file PC, desktop, GCoHire, R, class, and I'm going to call this fig1.tiff. I want this to be a TIFF file. And we can set the size in the same line. So I'm going to do width in inches equals 3.25. I'll do, do the same for height. And we want to set a resolution with this. A lot of journals require a minimum of 300 DPI. So let's do DPI equals 300. Okay, now the question then becomes, did it work? So I'm going to pull up figure 1. And I might have to stop sharing and reshare real quick just to make sure it shows. Here's figure 1. I think this turned out pretty good. 3.25 inches here, 3.25 inches here. We don't have any weird overlaps. We have a nice amount of space on the x-axis for the axis, or the y-axis for the axis title. Maybe we could have moved treatment down a little bit, but I think that's fine for now. We have our treatments, no-till with cover crop, tilled with cover crop. It looks pretty good. We can modify it from here in whatever way we want. What I'm going to ask you to do now is to, on your own time, go through that same script that we just talked about today. And I want you to not just one-up it, I want you to make this same figure, but with at least 2 upgrades to it. That could be adding a legend, that could be having colors. A legend probably wouldn't make sense, but you can always color the bars, right? The legend would just repeat what you have on the x-axis. Maybe change the bar colors to what we had before. Maybe modify it in whatever way you think is fun. Maybe rotate it, whatever you think. So that's up to you. 2 improvements on this. Maybe even make these borders a little bit thicker. With that, I look forward to getting your email. Please email me by Friday of this week, and I am looking forward to seeing what you make. Thank you all. Have a good rest of your week.